Hello, I have a video for you here on the Erta Ale Lava Lakes and the East African Rift. These lava lakes are a result of the East African Rift because the magma is so close to the surface that it just wells up and it takes the form of these stratovolcanoes. The Erta Ale Lava Lakes are located in northern Ethiopia, right here on near the coast, but not on the coast, because along the coast is this other country called Eritrea. And this is Ethiopia here. And the lava lakes are here, and you can see the massive amounts of lava that have already been deposited here. And these are actually stratovolcanoes. They're just low-lying volcanoes. They're not explosive. They just have magma welling up and down, depends on what the magmatic pressure is below. And you can see we've got quite a big area here. So here's an illustration showing the actual plates here. We have this area right here in the middle where my hand thing is. This is a thin spot. This whole area is very thin because it's being torn away in three directions. So the crust is really thin. And when you have a thin crust, you'll get shield volcanoes or stratovolcanoes, and the lava just wells up and it just covers the area and it builds the area up, but it's still thin. And then here's the East Africa Rift, which comes down through here. It's spreading apart. This plate here, which you'll see in the next photo, is actually moving to the right. So we have a big valley that's being formed here, and then you get the lakes in the valleys too. And then there's another part of it over here, and we can see the little triangles. I was wondering when that was going to come up. The little triangles showing the directions. Now we have a spreading zone right here in the Red Sea and the Gulf of Aden. Now these are spreading zones, and what's happening here is material is being added through a rift which has a big fissure through the middle of it, and material is going in, both coming out along the gray line and going north up to the right and then down to the left. But this material that forms here is actually going underneath this plate, and it's pushing this plate. So this is an old volcano area here where there's a lot of granite and stuff. So there's been a lot of volcanic activity here in the past for hundreds of millions of years probably. And so because this is really a subduction zone, we're getting the magma welling up to the surface here. And there's a dome over here. And oh, by the way, this African plate on the left is the Nubian plate now, and then the part that's breaking off here and going east is the Somalian plate. This shows what's going on a little better as far as the movements go. We have the arrows showing where everything's going. It's showing the African plate moving. It probably is, but there's still some subduction going on there. Now up here, just at the end of the Red Sea, there's a fault line that goes from here and goes straight up north through Israel and Jordan. And I actually have a photo of that. So this plate is sliding along, and so this is, you know, a slip fault here, strike slip maybe. And it's going, this part's going this way, and there's valleys are starting to form because of this, but it's not really a rift. And then we see here the The spreading up here in the middle is 17 millimeters a year, and then we have 7 millimeters down in the narrow part, and then 17 millimeters down on the lower part. So it's moving slowly, but it is moving. And then over here we have on the actual rift, the East African rift, 6 millimeters per year. So after a million years, you got, quite a few millimeters there, and eventually you'll have a spreading zone here in the middle, and this will fill in with the sea, and you'll have the same process with the subduction zones here and here will also be happening here. And I have just a few more illustrations here to show, kind of give you the lay of the land here. I don't want to go into too much detail. I just want to kind of do an overview on this East African rift and its connection to the Erta Ale Lava Lakes. And this illustrates what I've already stated. We have the spreading zones right in the middle, and that's where the oceanic crust is formed. And then we have here's the thinned crust, because this is being torn apart in 3 different directions. So we have really thin crust here. And then we have flood basalts over here too, but they're over here also. Here's an illustration showing what's happening geologically speaking. You have the spreading zone over here on the left. This is a mid-ocean ridge, and the material on the right side of this line here is moving this way, and it's being forced over here towards this plate, and when it hits the plate you'll get sediment buildup here, which later on forms like coast ranges and stuff, and you'll find a lot of chert there and that kind of rock. And then we have the heat generated down here is why this magma keeps coming up. It's got to go somewhere, and it wells out here. Now in our case, they're not huge big volcanoes that just blast open or anything, because of the crust is so thin. It doesn't really have to go up through mountains or a lot of material. It just gets there and then just wells out all over, and you get the lava flows. And then over on the right here we have like the Horst-Graben type faulting, which you will see in the rift zone. So this is actually like a rift here, and we have the magma coming up here, but it's not really the same process that you see on the left here. This rift is caused by what you see here on the right. It's not necessarily subduction when it comes to the East African rift itself, but later on it will. And just a picture showing the types of plumes that we have coming up. The super plume model, of course, is the East Africa model, where I think they're trying to demonstrate that entire East African rift is going to become quite volcanically active here in the near geologic future. So this is the lower left part of the East African rift, and you can see the lakes here. This is a data map, and you can see that this rift is a pretty huge thing. This is a realistic picture looking at the rift along a typical edge of it. You can see where the valley is being formed there. The plate is on the right, is moving to the right, and you can even see the cracks in the water down on the lower right. And then of course these valleys fill up with water and you get these huge lakes, and then later on the ocean will rush in. And here's the fault where this plate on the right is sliding northward, and that would be what Jordan is sitting on, and Israel is on the left side, and you can just about see the fault line going right through those lakes there. Those lines are map lines, but the fault goes right through there. You can always tell when you get lines of lakes too. And you get lots of cracks that are very scenic. Obviously, before the crack came along, all that water on the left would have continued on to the right, so the landscape totally changes. And the entire rift zone does make for some pretty dramatic scenery. And before we get on to the nice slideshow, which I'm going to end the video with, there'll be no audio. Here's a quick look at the geology map. You can take a snapshot of that or just kind of study it. I'll show the legend in a second here. And here's a quick shot of the legend. Note that they use the higher number, the older the stone, okay? So you just have to maybe take a look at that, and I'll just move it down here so you can see the rest of it here, in case you want to refer to the geologic map. It's quite a nice map. It's pretty detailed. I think a lot of this that they're showing on the geologic map is not necessarily right on the surface. And we'll take one last look at Google Earth here before we move on to the slideshow. You can plainly see what's going on here now. We have the rift coming down through here. This is actually a dome, and then those are those lakes, and the ledges I just showed are from this area here. And this would be the Somalian plate now, and this is the Nubian plate. And this plate here is moving this way, and here's our oceanic ridges here. These are spreading zones, and notice how faulted they are. And then up here we have one going right through the Red Sea, and then the fault line goes right up this way. So it's pretty visible from air too. And then of course this whole area here is the thin zone. The lava lakes are right there in the thin zone. And just to kind of give you an overview here. I guess I never really did zoom in, did I? So this is one like a huge, almost like a caldera here. These are walls that go straight up that are holding all of this basalt in here. We have one small lake and then the bigger one over here, and the levels on these go up and down, and if you get to the top then it floods over. And these aren't the only ones around here, but these are the Erta Ale Lava Lakes. And if you go to Google Earth, of course, you can go on the 360s here and check out all the photos. But I have some pretty good photos in the slideshow. And I don't know how close in we can go here and really see anything. But it's quite extensive. And this whole part here, of course, is a a shield volcano or maybe a stratovolcano. I'm not really sure. I haven't really studied it that much. So I guess it's on to the slideshow. And have a great day, and thanks for stopping by.